Hey guys, there's just a few more sections I need to cover to wrap up Pre-Calc B, and they all have to do with conic sections. Okay? The first one we're going to talk about is the parabola. Now, the whole idea with the conic section is that I'm taking a double helix cone, like you see right here on the left, and I am like, you can think of it like a blade, or it's like a plane, a sheet of paper. It's cutting through this double helix cone in such a way that it forms this shape. In this case, whenever the blade or the paper, the plane, whatever it is, comes through, it forms our parabola. The same parabola that we talked about back in Pre-Cal A. Now, there's a lot of different ways that this parabola can form, all right? Or the way that it could face, I guess. It can open up, down, left, right. It can actually open up and to the right. It can open diagonally. Any which way that you can think of, it can open. We're just going to concentrate on 4 ways that it can open in this video. Okay? Whenever you take your quiz, or whenever you're working out the problems, I'm going to be asking you to list its important parts. Okay? And so whenever I say the important info, or the important parts, that I'm going to want, here's what I'm talking about. First off, I'm wanting to know what the vertex is. The vertex is just going to be where it changes direction. Okay? And so it could be the leftmost point, as you see in this picture. It could be the max or min, like we talked about in Pre-Cal A. It could be the rightmost point. I'm interested in something called the focus. That will be something that I will want you to see, that I will want to see listed as well. And thirdly, I want to be able to see the directrix. Okay? I want to see it. I want it labeled. I want all that good stuff to happen on it. Now, let me just briefly talk about this. I'm not going to go into a lot of detail with it because I think this video will be long enough without doing that. But the idea with this is that if I was to choose any point on this parabola, okay, I'm just going to choose this random point up here marked by the letter, or marked by the X's. The idea is that if I was to draw a straight line from the focus to that X, it should be the same distance as the straight line that connects the directrix to that point. Okay? So those two distances should be equidistant if I'm drawing it correctly. I'm not going to get too hung up on that. I'll kind of show you a shortcut for making sure that you draw your parabola wide or skinny enough in just a minute. Now this is great note card material as well. All right, and so this is just something real good to have handy because depending on whether the graph opens up or down, or if the graph opens left or right, I'm using 2 different formulas for it. And so the first formula is right here. I'm going to be using this blue formula on the left if the graph opens up or down. Okay? So you see a lot of similarities with this that we had in Pre-Cal A. You see that my X variable is still being squared. And you just see some other general information that I'm going to talk about in some upcoming examples. We have a new variable in here, this P right here. If this P is going to be really handy for getting a hold of my focus and my directrix very quickly, because P is going to be the distance between the vertex and the focus. Okay? It's actually a directional distance, I like to call it, from the vertex to the focus. We still have our X's and Y's. X and Y is still going to be where the vertex lands. I think I said X and Y. H and K, that's going to be where the vertex lands. And then how I'm going to know whether it opens up or down is going to depend on whether the p-value is going to be positive or whether the p-value is going to be negative. More on that coming in an example. Now I've got to orient the whole parabola a different direction if it's going to be my y that's being squared. Okay, I'm going to be using this formula. Now, everything still is going to go very similar. My h and my k, notice that my h is over here with my x, and my k is over here on the left side of my y, that's still going to be my vertex right there. Okay, and that's where I'm going to start, is finding out what that vertex is. P is still going to be the distance that I go from the vertex to the focus. Okay, so whatever that distance is. And of course, it's going to, like I said earlier, it's going to be equidistant. So this value, or this distance right here, would also be P. And again, it kind of makes sense to me that if P is going to be positive, it opens in a positive direction to the right. Whereas if P is negative, it opens in a negative direction to the left. And that's just something you'll eventually understand more and more the more problems that we work. Okay? So let's try it. Let's try a really basic one. So, as you can tell, I'm not going to say identify this and this and this and this and this. I'm just going to say, and label its important parts. All right, so this is actually already in the standard form that I'm going to want this conic in. Y squared equals negative 16 x. You might be saying, well, there's not nearly enough information there. We had h's and k's and p's and everything else. Well, if that's the case, let me rewrite this, have it make a little bit more sense to you. I would argue that writing it like this does not change the value of that equation. I just threw in some zeros. And by throwing in those zeros, I'm able to note what my h and my k are. My h and my k is going to be at 0, 0. So this parabola is going to sit or come up to or left or right. It's going to butt into the origin. Okay. Next up, remember that whatever was in this spot right here, this is what my 4p was equal to. Okay? And so 4p doesn't really help me, but I could solve this. I could divide both sides by 4, and I can get that the p is equal to negative 4. Meaning that in order to go from my vertex to my focus, I need to go negative 4 units. Well, the question is, do I go down 1, 2, 3, 4, or do I go the negative direction 1, 2, 3, 4 to the left? And that's where you're going to have that screenshot handy, or a note card or something handy, where in this case I have my y squared. Whenever I have my y squared, my parabola opens to the left or to the right. In this case, it's not going to open down. It's going to open around this point right here. And then if I went 4 units to the left in order to get my focus, I'm going to go 1, 2, 3, 4 units to the right. My directrix. And the next question is, how wide do I make my parabola? And what I do is I cheat a little bit. Okay, I know that it's going to come. I know that my parabola should open something like this. Okay, but I'm not sure how wide it's going to be. So I'm going to move that drawing in just a minute. But ideally, remember that whatever lands here should be equidistant from these two, from this point and from this line. Okay? So let's remove all of this real quick. And let's keep that in mind, okay? Because what I'm going to do is I'm going to actually count this distance right here. And this distance right here is going to give me 8. And that should be how far I want to go away from this focus. If I come up 1, 2, 3, 4, 5, 6, 7, 8. I think I counted that right. 1, 2, 3, 4, 5, 6, 7, 8. It gives me 2 points that land here. If I go through those 2 points, I should get a pretty good drawing of my parabola. Again, let me show you that again. I went 8 units up and down from here because this point has to be the exact same number of units from the focus as it is the directrix. 1, 2, 3, 4, 5, 6, 7. So I know that distance right there was 8 as well. I'm just interested in this blue line right here, this blue parabola, and then make it so it's wide enough. a lot of new stuff going on with that. So before I turn you loose, you doing one on your own, let's do another one. I didn't label its important parts on this. Okay, remind me, I'm going to label the important parts this time. Again, it might help you to go ahead and put in the zeros. Okay, so once again, this thing is going to sit or stand, or it's going to butt up against the origin. And what a lot of people do is they look at this and they say, well, I see that the x is being squared. And they go back and they see that the parabola is going to open either up or down. They already have that in their mind. So that way, whenever they find this value p, it helps them out. Okay, so this value that's right here in front, that is what is going to equal my 4p. So in this case, the p is only going to equal 2. More importantly, the p is going to equal a positive 2, meaning that I am going to go up 2 units because my parabola has to wrap around my focus. And that also means my directrix will come down here. So I know my parabola is going to open up around this way. Okay, not sure how wide though. Okay, so let's cheat again. Okay, so whenever I'm cheating, I'm just counting this distance coming down. It's 4. So that's exactly how many units I'm going to count going out from the side of my focus. 1, 2, 3, 4. Big point there. 1, 2, 3, 4. Now, these red dots are 4 units from the focus, and they are 4 units from the directrix. So that means I can draw a more specific parabola. Let's talk about labeling its important parts. Okay, on one of the first slides, I said make sure you show me all the important info that's going on. Okay, so I'm going to want you to tell me the vertex. Even if the vertex, like this one, is at the point 0, 0, tell me 0, 0. I want you to tell me where the focus is. And this isn't going to change over the next few videos. These are all items that you're going to be telling me. So the focus, it's not 2. The focus is this point right here. It's 0, 2. And then finally, the directrix. Directrix is not a point, like I was about to do. It is a line. It was a horizontal line at -2. So I should get y equals -2 for the directrix. So I like to have all this information because sometimes, this might blow your mind, I get some students that don't draw just the neatest graph, and they get a little bit sloppy with their graphing. So that way I can say, well, as long as it looks like it's in the right spot, I can say, well, I wonder where they were trying to put this. I can come over and find it easily. And that'll get more important on the next couple of conic sections that we talk about. Okay, I want to work one with you that does not have a vertex on the origin. Looking at this one, the vertex, someone's going to say the vertex is at 2, -3. But remember what we talked about in pre-cal A? We said that if it's in parentheses, we always have to take the opposite. And if you go back and look at your formula, we still need to do the same thing. In this case, the vertex is actually going to be at -2, +3. -2, 3. Our vertex is hanging out right here. Now think about it. Which way is this parabola going to open? Is it going to open horizontally, left or right, or vertically, up and down, up or down? That's the key right there. You have to look and see that the x is being squared. So if the x is being squared, it's going to be like the last one. It's going to open up or down. Okay? So let's try to figure out which way it's going to open. So I'm going to bring this 20 over. This 20 is important right here because it's going to help me get my spacing down. So p is equal to 5. And it's opening up or down, and p is going to be a +5, meaning I want to move in the positive direction from my vertex, 1, 2, 3, 4, 5, in order to get my focus. That also means I can move down 5, 1, 2, 3, 4, 5, to get my directrix. So I could go ahead and list out all my important features. Let's see, my focus, it landed at -2, 1, 2, 3, 4, 5, 6, 7, 8. Meaning that my directrix landed at y equals, let's see, it's -2. And I'm just counting on that. There's obviously little formulas that we could use. I think it's easier just to count on it. Now let's get a more adequate drawing of this. Now I got a big distance right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 units from the directrix to the focus. So my cheat on this is to go 10 units each direction from my focus right here to get my other 2 points I need for my parabola. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to run out of room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just act like it's right there. So yeah, the bigger that p-value, the wider your parabola is going to be. It needs to be full credit, okay? You don't have to draw, I don't have to have this guy in there. But I want to see your parabola, I want to see your vertex, focus, directrix, and everything, everything listed out over here. All right, you try one. We're going to hit pause on the video, and then you work it, and I'll work it, and then we'll see if we match. And there's what I got. Notice on the directrix this time I used x equals 9 instead of y equals 9 because x equals going to give me that vertical line. Now let's try it in reverse. They're going to give me some information about the parabola, and I want to write an equation for it. I can already tell you a lot about this equation, that it's going to be something squared equals something times p, and I can plug in whatever I need to for that p. All right, so I can kind of get a skeleton for it. I guess I can't really tell as much as I thought I could, because I don't know if this thing opens left or right or up or down. And so I think that the easiest way to solve this, and of course there's formulas for all of this, but I think it's just a formula overload. I think the easiest thing to do is just go ahead and just do a rough sketch as to what's going on. Okay? It says that I want the equation, and the focus for my parabola is at 0, 3.5. 1, 2, 3.5, 7 halves. And I have a directrix down here at 1, 2, -3.5. Well, remember, what's halfway between your focus and your directrix? Your vertex. And remember that your parabola has to open around your focus. So there's my rough sketch. This part over here is not going to be graded. That's just where I'm kind of showing my work to get my bearings right. Because I can tell now that the graph is opening up. Okay, and if the graph is opening up, that means that my x is going to be my squared variable, and then my y will be on the right side. Now I can go ahead and get my h and my k. My h and my k is going to be 0, 0. You can throw those in. That's fine. I'm not going to count that wrong. And lastly, I'm going to have 4 times whatever the p-value is. And remember, the p is directional. So the p is how far I'm going, not from the directrix to the focus, but from the vertex to the focus, which is 3.5 units, or this 7 halves that we've been using. I do want that simplified a little bit. You can leave it x minus 0 squared, that's fine, but I'm going to go ahead and just call it x minus 0x. And then that's like 28 over 2, so 14. This would be my answer. Lots I'm checking for on that. I'm making sure that your vertex is in the right spot. I'm making sure your p-value is correct, positive or negative. And I'm making sure that you squared the appropriate variable. Okay? So I think it's a lot quicker working it backwards. I like the ones where we work them backwards. So I'll let you guys try this one. I won't get lucky enough to have it centered on the origin, but I think you can figure it out. So go ahead and hit pause, and then we'll both work it out. Here's what I have. Got kind of some weird numbers in there, but they ended up ironing out. Make sure you get this. Biggest mistake I think I'm going to see on this is people not putting the -2 over here with the x, and then the 3 with the y. Okay, the h always has to go with the x, the k always has to go with the y. Here's 9 practice problems. Try to make it so your quiz is something close to these. So if you have any questions on these, let me know. I'll see you guys next time.